rest. It is a line having all those points which are having instantaneous centers of zero velocity. So, by definition, this becomes the axis of rotation. So, essentially what you are doing, you are having omega 2 about, let's say, z axis and omega 1 about the x axis. At any instant you can combine these two and you can form an instantaneous axis. Okay, and the net omega of the body will be about this instantaneous axis. What do I mean by that? This is your disc. This is the shaft. So if you want to plot the vectors, angular velocity vectors, this is omega 2 vector along the omega 2 axis. This is omega 1 vector. Why is omega 1 and omega 2 treated as vectors? What we studied in the previous class. Finite rotations are vectors or not vectors? Infinite rotations are, and what is omega by definition? D theta by dt. So we saw the Euler's theorem also that if you give rotations about arbitrary axis, the net motion can be regarded as rotation about a single axis passing through that same fixed point. So you can see that this is the fixed point in question O, and this does not move. And you will find a locus of points along this line which is having instantaneously zero velocity. How do we arrive at that? We said that, okay, let us take some point. Here it is x and here it is y. So omega 1 y, due to this, if someone is sitting on the rotor, he will see that omega 1 y is going in. Someone here will see that omega 2x is going out. They are oppositely directed. But let's say your x and y share a specific relation such that omega 1 y is equal to omega 2 into x. So y by x is omega 2 by omega 1, which is equal to tan theta. How else can you get this locus? If you look at the vectors omega 1 and omega 2, how do you get the resultant? This resultant omega is omega 1 plus omega 2. What is the direction of this resultant? Magnitude of omega 2 divided by omega 1. Inverse tan of that, right? If you recall your vector addition rules, so you get, of course, if you do vector addition, the direction and the magnitude is encapsulated. If you want to break it, then it is omega 1 square plus omega 2 square, because omega 1 and omega 2 are at right angles to one another in this case, okay? And the direction will be omega 2 by omega 1. So this theta is same as this theta. And physically, if you take a photograph, if you mark black dots here, you will find that these black dots appear quite clear in the picture. But all the other parts of the disk, they appear blurred. Only those black dots along that line will appear clear. But tell me one thing, this is the instantaneous axis of rotation. The name suggests that is this a fixed axis of rotation? नाम में ही है instantaneous. So at this instant you are having some direction of omega. Okay. So along the instantaneous axis you are having the net omega. That makes sense, right? So for the entire body the omega can be regarded about this axis, and velocity of any point is omega cross r. That will be omega 1 plus omega 2 cross r, like we had it. But if you look at this picture and if you try to visualize, how is this omega moving? Omega matlab, when I say omega, I mean the total omega. When I talk about omega, I mean the total omega. How is it? At this instant it is like this. Omega 2 is fixed in space, but omega 1, what will happen? It is rotating. Due to which what will happen? Omega will rotate. So do you agree that this will trace out a cone? The surface of the cone, any lateral slant line on the cone is actually your omega vector. That omega vector can be anywhere on the surface of this cone. This is known as your space cone. If you fix omega, this, let's say you have this line and some way you imagine this to be attached on the rotor. Okay. If it is attached onto the rotor, how will it move? Do you understand? This particular line, let's say you latch it with the rotor. How is rotor moving? Like this. So this line will also have the same omega as that of the rotor, and you trace out another cone which is called the body cone. Now what you can think is this body cone is a cone which is executing pure rolling on the space cone. Pure rolling में क्या होता है normal case में? If this is a wheel which is in pure rolling, then this is the instantaneous center of zero velocity. This is the body cone which is rolling on the space cone. Can you visualize? This cone is rotating and it is circling on the space cones. Yes. Second case is body cone. Okay, body cone we trace when we think that instantaneous axis is moving with the body. Okay, so if it moves with the body, this is the angular speed of the body. So instantaneous axis, if you fix it to the body, it will move like this. Okay, but when it moves like this, you can, on the space cone, you can imagine that it is rolling on the space cone. Whenever it will move on the space cone, it will start traversing the space cone. The body cone starts pure rolling on the space cone. Like this becomes the body cone, let's say the example, and this becomes your space cone. Now in this case, it is a point contact which is at rest Here this is the line of contact which is at rest. So this line of contact is instantaneous axis of rotation. We are conceiving the motion of instantaneous axis of rotation as a line of contact between body cone and the space cone, and the body cone is executing pure rolling on the space cone, and always that line of contact between the space cone and body cone is instantaneous axis of rotation. More importantly, space cone is the absolute motion of the net angular velocity. What is your net angular velocity? Total angular velocity. In the absolute frame, how it moves? Like this. Body cone, someone who thinks that he is on this shaft, rotor, he will see that it is rotating like this. So this, when it rotates, you can consider it that it is rolling, because once you start rotating this, if this is no slip, it will start rolling. For pure rolling, there is no slip. Always at pure rolling, your point of contact is at instantaneous center of zero velocity. Can you prove that this is at zero velocity? Forget space cone and body cone. I am saying that this is omega and this is r and this is v, the speed of the center of mass. How do you prove that point P is at zero velocity? V minus r omega. But how do you get the speed of this point as v minus r omega? So what you are saying is that if someone is on the road, if you choose coincident point, on the road he will see that it is having r omega in this direction. But no, point P is on the road, it is not having translation. One thing you can say that this is no slip. If it is no slip, if you take two coincident points, one is on the road and one is on the this point on the disc. So if this doesn't have to slip, then the absolute velocity of the point on the wheel must be zero. That is one logical way of looking. And other thing is that pure rolling is, what is pure rolling? It is plane motion. Plane motion is the combination of rotation and translation. So if you look at translation only, then all speeds are v, v, v. If you look at pure rotation about the center, this is r omega, this is sorry, how do I look at it? Like this. This is r omega and this is r omega. Now if you add these two, v is equal to r omega, you will get velocity of this point to be 0. So here also, how did you get this zero velocity? You found that okay, omega 1 into y must be omega 2 equal to x. I can get a line which is having zero velocity. And along this line you are having the contact, the contact between the rolling body cone on the space. Okay. This is just a visualization tool, and sometimes it is helpful in computing. Space cone particularly is helpful in computing this particular thing. angular acceleration. We will see how. Were you able to understand the second case? The second case. So should I erase this? So here you are having a shaft and you have a wheel. So how is the shaft moving? So it is moving in this direction. So you will find that this is the direction of omega 1. So what I am doing, I am curling my fingers like this, I get omega 1. So if it is omega 1, it will move along this track, and if this moves along this track, this rotates in this direction. Do you understand that if this moves as omega s, then the wheel will move along this direction, and that's why the omega p must be downward, the thumb must point downward. So you will find this to be omega p. So at this instant, passing through this fixed point, you are having two angular velocities, omega p, and then here you are having omega 1. What is the fixed point? Now this is a point of zero velocity, and again this is rolling without slipping. So this is also instantaneous center of zero velocity. To draw a line, how many points do you need? 2 points. So you can. So obviously this will be the direction of total omega. What is this total omega? Omega 1 plus. How is the absolute motion of this omega 1? This is the space force. And this will be the body. Here it is more easy to understand.
How to know which one is space cone and which one is body cone?
How to know which one is space cone? So first we will try to understand how to know which one is space cone. So when you want to understand what is space cone, ask two questions. पहला question, net omega कहाँ पे है? क्या है? What is the total omega? So here you tell me where is the total omega? This point and this point you have joined. This is the total omega. How you get omega 1 vector plus omega p vector? You will get total omega. Now the thing is, ये जो omega vector है, how is it moving in space? How is it moving in space? Close your eyes, you see. You can imagine this to be a rigid, in fact, part of this cone. You can imagine this to be part of, no, not this, what is this called? मतलब wheel and shaft का एक part ही समझ लो. Though it is not physically a part, but you just think that it is part of that. Now as the wheel moves, this starts contacting different points, right? So this becomes the space. The motion of the total angular velocity that traces a cone. टोटल एंगुलर वेलोसिटी कैसे ट्रेस करता है एब्सोल्यूट मोशन, वो है स्पेस कोन। एब्सोल्यूट सेंस में कैसा है? बॉडी कोन रिलेटिव चीज है। रिलेटिव चीज मतलब इफ यू टेक द इंस्टेंटेनियस एक्सिस ऑफ रोटेशन एंड यू फिक्स इट टू द बॉडी, फिक्स इट टू द बॉडी मतलब ये जो मेरा व्हील है उसका पार्ट हो गया, व्हील एंड शैफ्ट का। तो अगर व्हील एंड शैफ्ट का पार्ट देखेंगे तो कैसे मूव करेगा? ऐसे ऐसे मूव करेगा। जैसे ही ऐसे मूव करेगा इट विल स्टार्ट रोटेटिंग। सो दिस बिकम्स योर स्पेस कोन and this becomes the body. So it is like you have a inverted cone which is the space cone, and then you have another cone which is rolling on the surface of the inverted cone. Are you able to get this?
ऐसा कंसीडर कर सकते हैं क्या ओमेगा 1 की वजह से जो कोण बन रहा है वो
ओमेगा 1 के वजह से जो कोण बन रहा है वो बॉडी कोण, और ओमेगा p के वजह से स्पेस कोण। Yes, you can consider. So like Anupam is saying, the instantaneous axis moves along the space cone with this speed, omega p. But you have to remember, omega का absolute जो motion है वो है space cone. That's very easy to understand, right? ये दो शाफ्ट था, एक शाफ्ट ऐसे रोटेट कर रहा है, एक शाफ्ट प्रिसीजन कर रहा है। तो क्या हो रहा है? ऐसे ऐसे ये घूम रहा है। तो ये तो वहीं पे रह गया, बट ओमेगा 2 का बार बार डायरेक्शन चेंज कर रहा है। तो नेट का डायरेक्शन ये हो गया नेट ओमेगा, ठीक है। एंड इफ दिस इज द प्रिसीजन स्पीड, नेट ओमेगा इज चेंजिंग लाइक दिस। तो ये क्या ट्रेस कर रहा है? स्पेस, ठीक है। उसके बाद this net omega you think that it is attached to the body, so how is it moving? Like this, body. And this body cone, it should move in a way such that it executes pure rolling on the space cone where the line of contact is the instantaneous axis of rotation. तो ये जो मेरा बन रहा है ये है instantaneous axis of rotation। ये हो गया body cone, ये हो गया हमेशा, and always all of these axes are passing through that particular fixed point. Clear? Okay. One thing I have understood with this batch in particular, that I have to move little bit more towards the problems. If I leave it on you, I can't see the light at the end of the tunnel. So you should practice more and more in the class, even if it means covering less content. As far as the mid-cell is concerned, handful of you, 3 to 4 of you have done well, but rest of you need serious help. So yes. Now this is the motion of the body cone on the space cone. Before you look at these diagrams, just consider the space cone. If I need to consider the space cone, can I show like this? This is your, इसको क्या बोले, omega 1 मान लो. This is omega 1 and this is omega 2. This is the net omega, मतलब omega 1 plus omega 2 as per triangle law और as per parallelogram, ठीक है। And this is the space cone. तो एक चीज मुझे बताओ, इसका इस वेक्टर का रेट ऑफ चेंज निकालना। I told you ना, space cone is used to get d omega dt. ग्राफिकली क्या होगा? d omega dt मतलब क्या? ये ओमेगा वेक्टर है, इसका रेट ऑफ चेंज विद रिस्पेक्ट टू टाइम, ठीक है। नाउ यू सी, actually answer is already given over here. It will be tangent to the space. क्यों? क्योंकि मान लो ओमेगा एट सर्टेन इंस्टेंट ऑफ टाइम may be here, at delta t it will be here. Now as you shrink delta t to 0, the change in the vector will come along the tangent. तो स्पेस कौन जरूरी है? हम जब d ओमेगा dt निकालना चाहते हैं, that means omega dot that will always be tangent to the space cone. When you say not constant, there are two things here. As you I am about to discuss this, it is written general case, but कोई भी केस में whether omega 1 omega 2 are constant in magnitude or not, the tangent to the space cone will always be. Let me explain a little bit more. Here the way you are seeing is that the omega is changing in length. पहला केस जो है, you see these cones are constant in size. ये cones जो है ये size में constant है, क्योंकि omega 1 और omega 2 का जो magnitude है वो constant. But if you can understand that if this omega 1 changes in magnitude, omega 2 also changes in magnitude, then the size of the cones will also change with time. So here you see that the size of the cones are changing with time, which is the general case. But whether it is a general case or a case which we are considering where omega 1 is constant, omega 2 is also constant. When I am just saying constant, I mean the magnitude. Because direction, if you see, direction of omega 1 is not constant. A quick question, यहाँ पे दो एंगुलर वेलोसिटीज है, एक ओमेगा 1 है, एक ओमेगा p. ओमेगा p, if the magnitude is constant, then it becomes a constant vector, क्योंकि इसका डायरेक्शन चेंज नहीं होगा. बट ये जो ओमेगा 1 है, इसका डायरेक्शन चेंज. तो डायरेक्शन चेंज होने से कोई प्रॉब्लम नहीं है. बॉडी कोन, स्पेस कोन का जो डायमेंशंस है, दैट इज फिक्स्ड. But suppose if this accelerates or retards as it moves, then the size of the cones will change. But graphically, this notion d omega dt will always be tangent to the space, whether it is variable omega or whether you can visualize it over here. ये figure को The first is a simple fixed axis rotation. पहला केस क्या है? एक ओमेगा है और एक वेक्टर है. In the first case, you are having a vector. Take this blue marker as the vector, and it is rotating about this black marker axis. So how will it move? It will move like this. इसका rate of change क्या होगा? इस वेक्टर का rate of change ओमेगा क्रॉस r. Fixed axis rotation है ना about this, so it will be omega cross r. Now what is happening? इस केस में क्या हो रहा है? Can you understand? ये जो ओमेगा है, total omega, it is undergoing fixed axis rotation about the precision axis. It is executing fixed axis rotation about the precision axis. तो ये d omega dt क्या हो जाएगा? ओमेगा p cross. The same example यहाँ पे try to relate. ये जो total omega है, net omega, that is moving with some speed, angular velocity, right? हमने जो भी केसेस देखा, पहला ये वाला जो केस है, इसमें ये टोटल ओमेगा है, and this total omega is moving with angular velocity omega p. तो इस ओमेगा का रेट ऑफ चेंज क्या होगा? ओमेगा p क्रॉस ओमेगा. सिमिलर टू द फिक्स्ड एक्सिस, एक कोई वेक्टर है जो एक सर्टेन एक्सिस में ओमेगा से रोटेट कर रहा है, तो उसका रेट ऑफ चेंज क्या हुआ? ओमेगा क्रॉस, जस्ट बिकॉज ऑफ द डायरेक्शन चेंज। अगर मैग्नीट्यूड भी चेंज होगा देन यू विल ऑल्सो हैव टू राइट प्लस डी ओमेगा डी टी इन दिस पर्टिकुलर फ्रेम, ओके, ड्यू टू द मैग्नीट्यूड चेंज। This is due to the direction. Right now we have not talked about this, but this will also come. When it is constant, then it will only be. ये क्या है? ये वो वाला केस है जब हम लोग 2D में एंगुलर एक्सेलरेशन लिखते हैं। 2D में एंगुलर एक्सेलरेशन कैसे लिखते हैं? ये सर्कल है, दिस इज ओमेगा एंड दिस इज अल्फा। 2D में तो डायरेक्शन चेंज होने का कोई प्रॉब्लम नहीं, तो इफ दिस d omega dt here implies only the magnitude change, तो ये वही वाला कंपोनेंट, and this one is due to the change in the direction of omega। तो टोटल ओमेगा कैसे चेंज कर रहा है? इट इज मूविंग अलोंग द स्पेस कोन, और किस स्पीड से मूव कर रहा है? ये प्रिसिशन स्पीड से मूव कर रहा है। इज देयर एनी कंफ्यूजन? So this is an analogy drawn कि एक वेक्टर अगर ओमेगा अबाउट रोटेट कर रहा है तो उसका रेट ऑफ चेंज हुआ ओमेगा क्रॉस आर। सिमिलरली एंगुलर वेलोसिटी वेक्टर भी अगर ऐसे प्रीसेस कर रहा है ओमेगा से तो उसका रेट ऑफ चेंज हुआ ओमेगा क्रॉस आर। दिस आर शुड बी रिप्लेस्ड बाय ओमेगा। इज दिस क्लियर? अब जो ओमेगा वेक्टर है हमारा वो अब डायरेक्शन चेंज कर रहा है, ठीक है, और किस रेट से वो डायरेक्शन चेंज कर रहा है? ये प्रिसिशन एंगुलर वेलोसिटी। सो द रेट ऑफ चेंज विल बी ओमेगा p क्रॉस ओमेगा, और इन दिस केस एज शोन इन द स्लाइड इट विल बी दिस। दिस इज जस्ट ड्यू टू द डायरेक्शन चेंज। इफ देयर इज आल्सो अ कंपोनेंट ऑफ rate of change of this vector, so that there will be further another time derivative. If this doesn't make sense as of now, don't be worried. As you look at the problems, it will start making sense. इसमें कोई question है? Any questions? But remember, when you are one clarification, ये जो omega dot है, दिस ओमेगा डॉट, इस केस में जनरल केस में दिस एनकम्पासेस बोथ डायरेक्शन चेंज एंड मैग्नीट्यूड चेंज। ग्राफिकली जो स्पेस कोन मैंने बताया कि स्पेस कोन पे टेंजेंट है ओमेगा डॉट, तो वो ओमेगा डॉट टेक्स अकाउंट ऑफ एवरीथिंग। तो जनरल केस में क्या हो रहा है? डायरेक्शन भी चेंज हो रहा है, मैग्नीट्यूड भी चेंज हो रहा है, but tangent to the space cone is always omega dot, ठीक है। So if graphically if you are able to find space cone, you will be find the angular, you will be able to find the angular acceleration. Yes, anything? Okay, just a simple problem here. Point. Okay, before we do this problem, we should also look at some basic kinematic relations. So here if you want to find the speed of a particular point on the disk, let's say P, so you have to get the position vector r and you have to do omega cross r. But what is this omega? Total omega 1 plus omega 2. Now if you want to take the derivative, so you differentiate both sides, you will get omega cross r, omega dot cross r. This omega dot is what? Tangent to the space cone. It is also equal to omega p cross omega, and if it is variable in magnitude, then this also. Okay, this entire thing, that is omega dot. That is omega dot cross r. Then omega cross of r dot. R dot क्या है? Again omega cross r. And what is this omega? This is the total omega. Total omega about the instantaneous axis of. Now you want to use this, you have to apply it to a simple problem here. So this particular arm, this can rotate about the x-axis as you can see, and further this OA arm rotates about the z-axis with this speed m. So that is what is given, 0.8 meter arm OA of this remote control mechanism, and simultaneously these two rotations are applied. Now for a particular position where beta is 30 degree, you have to determine the angular velocity of OA. तो पहला क्वेश्चन है एंगुलर वेलोसिटी ऑफ OA क्या है? एक रिजिड बॉडी, और OA का क्या क्या रोटेशंस हो रहा है? एक बीटा डॉट है, किस एक्सिस के अबाउट में? एक्स एक्सिस के अबाउट में। और क्या रोटेशन है? एन, जेड एक्सिस के अबाउट। ये दोनों रोटेशंस कहाँ इंटरसेक्ट कर रहे हैं? क्या वो फिक्स पॉइंट है? तो ये सब चीजें आपको सोचना होगा। जैसी प्रॉब्लम है, क्या रिजिड बॉडी है, किस के अबाउट में रोटेशन हो रहा है, वो रोटेशंस क्या एक फिक्स पॉइंट के थ्रू पास कर रहा है। बहुत बार ऐसा हो सकता है, which I love to do, what I'll mount this on a car, so this no longer becomes a fixed point. But in the relative sense, that analysis will hold. You will first consider O to be fixed point, then you will add the motion of O, which is the motion of the car. But पहले ये सब चीजें आपको देखना है। So what is the total omega? Total omega क्या क्या है? एक हुआ ये n z कैप, दूसरा हुआ बीटा डॉट x। तो टोटल ओमेगा इन दोनों का वेक्टर एडिशन, and whatever is the direction of that total omega, that will be the instantaneous axis of rotation. So you find out the angular velocity quickly. Also, while you are reading the question, देख लो वो हर मैग्नीट्यूड कांस्टेंट है या वेरिएबल। तो क्या है इसमें? दोनों रोटेशंस कांस्टेंट कांस्टेंट। Yes. How will be the space cone looking like? Mentally, ये मान लो ओमेगा इंस्टेंटेनियस ओमेगा है, स्पेस कौन कैसे जाएगा? किस स्पीड से जाएगा? n क्या? n इंटू k क्या है? ये हो गया, ये है एंगुलर वेलोसिटी ओमेगा। तो रेट ऑफ चेंज ऑफ ओमेगा क्या हुआ? डी ओमेगा dt. That will be what here? What will you write? n into ओमेगा, मतलब n into k कैप क्रॉस ओमेगा। तो इस ओमेगा में दो कंपोनेंट है। Your omega is n into k cap plus beta dot I cap. Now if you want to do d omega dt, there is another way of looking at it. एक और तरीका है। जब d ओमेगा dt करेंगे तो देखेंगे कि ये d dt n कैप dn dt जीरो है या नॉन जीरो, सिर्फ स्केलर। dn dt स्केलर है ना, जीरो है या नॉन जीरो है? जीरो है। क्यों जीरो है? कांस्टेंट है। d के dt वो भी जीरो है। अब यहाँ पे आते हैं बीटा डॉट, डी बीटा डॉट डी टी जीरो है, जीरो। बीटा डॉट डी आई डी टी नॉन जीरो है। क्या है डी आई डी टी? ओमेगा एन करेंगे। What I am doing it, I am recognizing this x, y, z to be fixed along the with the this rotation. ये जो रोटेशन है उससे फिक्स्ड है। तो मेरा z हमेशा फिक्स्ड है, बट x और y रोटेट कर रहे हैं। ये भी एक तरीका है देखने का, ठीक है। So you can write dn dt k which is 0, n dk dt which is 0, beta dot dt I is 0, then beta dot di dt. And what is di dt? k cross I. K cross I क्या होगा? J. So your angular velocity is beta dot n. और एक क्या तरीका है इसको करने का? ओमेगा का दो कंपोनेंट बताइए। वन इज ओमेगा प्रिसिशन एंड ओमेगा स्पिन। स्पिन मान लो ये है बीटा डॉट आई और प्रिसिशन है n और k। नाउ यू टेक टाइम डेरिवेटिव। तो b ओमेगा p dt, इस केस में प्रिसिशन एंगुलर वेलोसिटी चेंज कर रहा है? नहीं चेंज कर रहा है, क्योंकि मैग्नीट्यूड भी कांस्टेंट और डायरेक्शन तो हमेशा वर्टिकली अपवर्ड। सो दिस d ओमेगा p dt इज 0। नाउ d ओमेगा s dt, ओमेगा s इज दिस पर्टिकुलर वेक्टर। लुक एट माई मार्कर, ये है ओमेगा एस। ये कैसे चेंज कर रहा है? ऐसे, राइट? क्यों ऐसे चेंज कर रहा है? क्योंकि n इस तरह से। तो इसका क्या हो गया? कोई भी वेक्टर, यू रिमेंबर दैट फॉर्मूला विच आई गेव इन बिफोर मिडसम, एनी वेक्टर विच इज रोटेटिंग विथ ओमेगा इज ओमेगा क्रॉस रो। अभी थोड़ी देर पहले भी मैंने बताया था पहला जो केस। सो व्हाट यू विल गेट, d omega s dt will be omega p cross omega s. omega p क्या है? n into k cap beta dot I cap will become n beta. This is angular acceleration. तो एक जो बड़ा डिफरेंस हमें देखने को मिल रहा है, 2D में एंगुलर एक्सेलरेशन सिर्फ मैग्नीट्यूड चेंज के वजह से होगा। इससे पहले जो भी प्रॉब्लम्स की हैं उसमें 2D में angular acceleration was due to magnitude change, but here you will find that angular acceleration is also due to direction change of. इसको लेके कुछ भी क्वेश्चंस है यू कैन आस्क. दिस इज मोस्ट फंडामेंटल. Chapter 7, example problem. Okay, moving on to the second part, third part, velocity of point A. What is velocity of point A? Use these relations which were given. Omega cross R. So omega cross R. What is R over here? Use the given set of axes. So it is 0.8 cos 30 j 0.8 sin 30. You should also be careful about the axis. इस केस में axis दिया हुआ है. तुम लोग ट्रक के प्रॉब्लम में x और y को हॉरिजॉन्टल लिए हो, जबकि it would have been very simple if you had taken x along that ladder. That makes sense. So you had to write cos 30 sin 30 और करके made quite a nasty expression. You have made calculations. यही x, you understand what I am talking about, that truck problem. Some truck was there and here you had this k. Instead of choosing x and y like this, some of you have chosen like this. But here they have chosen x and y like this, so we are moving as per. And omega we have to find out first. Nk you have to take the cross product. Nk beta dot I cross this plus this. How will you get acceleration of point A? Again omega dot omega cross. Now remember one thing, एक चीज ध्यान में रखना, ओमेगा क्रॉस आर तुमने पहले ही कर लिया, यहाँ आने के बाद फिर से करने मत जाना. Whatever v you have written, you just replace it over. Have you understood? Tomorrow, do you have any slot which is vacant for the second half, 5 to 6? Class?